Guys, today we're looking at exercise 6i, which is addition of ordinates. This is a little bit tricky. We're looking to sketch the graphs of y equals 2 sine x and y equals 3 cos 2x for 0 to 2 pi. We want to use the addition of ordinates to sketch y equals 2 sine x plus 3 cos 2x as well. So I'm going to start by thinking about the normal graph of 2 sine x. And I've sketched it in here. So what we can see there, the amplitude is 2 and the period is 2 pi. Because there's a 2 at the front, that means amplitude 2, and the period is always 2 pi divided by whatever's before the x. There's nothing before the x, so that means it's a 1. So 2 pi divided by 1 is 2 pi. There it is there. I'm also going to sketch the graph of y equals 3 cos 2x. So for this one, my amplitude is 3, because that's the number at the front. And then my period is going to be 2 pi divided by 2, which is just pi. Notice that what that means for the period is that the time it takes for your graph, or the space that it takes for your graph to go one complete cycle. So that's going to be the period. So in this one here, in the first one, y equals 2 sine x, the time it takes to go one full cycle before it starts repeating itself is 2 pi. So that's why it looks like that. Whereas for the second one, where my period is pi, it means that it takes only pi rather than 2 pi to go one complete cycle before it starts completing itself. So here is pi, and then it goes twice because we go all the way up to 2 pi here. From that, let's see how we can use the addition of ordinates to sketch 2 sine x plus 3 cos 2x. Notice that 2 sine x plus 3 cos 2x is just the two graphs we've already drawn added together. We've done addition of ordinates before. Now, what I'm going to do, I'm going to choose some points or some x values where I can add together my values from my two graphs to find the new value for my combined graph. So I'm going to start with x is 0. That makes sense, because then we have a point at the very start of our domain there, or our values for x. So when x is 0, y is going to be 2 sine 0 plus 3 cos 2 times 0. So notice I've just substituted 0 into my equation there. That's going to give me the point 0, 3. Let's try the point pi on 4. Where x is pi on 4. So when x is pi on 4, y is going to be 2 sine pi on 4 plus 3 cos 2 pi on 4. That's going to give me pi on 4 and 2 over root 2. The next value I'm going to use is pi on 2. So that's going to be y equals 2 sine pi on 2 plus 3 cos 2 pi on 2. And that gives me a value of pi on 2 and negative 1. Let's now try for pi. Notice that I'm using the points of one of my graphs, and plus I did an additional point of pi on 4. When x is pi, y is 2 sine pi plus 3 cos 2 pi, and that is pi and 3. And finally, when x is 3 pi on 2, I get y equals 2 sine 3 pi on 2 plus 3 cos 2, 3 pi on 2. Which is negative 5. So 3 pi on 2 and negative 5. Let's now put all those points together, and I'm going to now be able to sketch my graph. There it is there. I just plot in the points as I would usually. So here is 0, 3. Here is pi on 4 and 2 over root 2. Here is pi on 2 and negative 1. Here is pi on 3. Here is 3 pi on 2 minus 5. And I've also put in 2 pi and 3. What we can see is that even if you just look at the graph and if you add together the points of the other two graphs, so for this 2 pi value, we can see that for our graph of 2 sine x, we have a value of 0. Yeah. Whereas for our graph of 3 cos 2 pi, we have a value of 3. So when I add those together, I get 3, which is my value for my graph when I add those ordinates together. You'll find that each part of the yellow line is a sum of the other 2 lines. And that's all we need to do for addition of ordinates.